Production is down, pager duty is ringing, Slack channel is exploding, manager is asking for updates, customers are affected, and now someone says check the run book. But where is the run book? Confluence, GitHub, Slack, SharePoint, or maybe some old incident documents, or in someone's head. This is one of the most common problems that we see in each and every team. Most teams don't have documentation problems. They have a documentation retrieval problem. The information exists, it is somewhere sitting, but during an incident, finding the right information fast is the real challenge. So, in today's video, we are going to build an AI Runbook Assistant. By the end of this video, you will learn how to structure operational runbooks, how to build a searchable runbook index, how to retrieve the most relevant runbooks for an incident, how to use local AI with Ollama and Mistral, how to generate incident specific guidance, how to create a final incidents guidance report, how to keep humans in control of production decisions, how to adapt this particular workflow for your own internal documentation. This is not just another chatbot demo. This is a practical DevOps workflow. You can replace the sample runbooks which I am showing with your own Confluence or GitHub README files or any other sources which you have. The architecture which I am going to show will remain the same. If you enjoy practical AI and DevOps projects, hit the like button, subscribe if you are not already subscribed to the channel, and comment runbook if you want me to release the full source code that I am going to use in this video. Now let's build it from scratch. So, what exactly is the problem? Most companies already have documentation. They have runbooks, they have wiki pages. They have good old README files and some incident reports. There is a lot, but when production goes down, every team member will ask each other, where is the run book? This is common across multiple different companies, multiple projects. And also, not only where is the run book, which document is correct? And also, is the page outdated? Or let's say, who owns this particular service? And also, what should I check first? These are kind of very few points I'm trying to put it down here. This is why runbook retrieval matters. During an incident, first 10 minutes are extremely important. If an engineer is spending, let's say, those 10 minutes Searching through documentation, those 10 minutes are very expensive. If the engineer with less experience follows the wrong run book, that can make the incident worse. So, the goal of this project is very simple. Ask a question. Find the right run book. Generate practical guidance. And also validate before taking any action. This is not about AI replacing engineers. This is about AI helping engineers find the right operational knowledge faster. Now let's look at the project structure. I'm going to jump back to the Visual Studio Code. Here we have a runbooks folder. This contains sample operational runbook. For example, I have these in place for this video. We also have an incidents folder. I have a sample incident in place. We have an index folder which is empty right now. This will store the searchable runbook index. We have a reports folder. This is where the retrieved runbooks, AI answer, and final guidance report will be generated. These are some Python files. For example, the main Python files are build underscore index. We have search underscore runbooks. And also we have AI Runbook Assistant.py. And finally, we have final report.py. The workflow is very simple. I'm going to write down the workflow here on the blackboard so that you understand the full architecture. We are going to start with incident question, followed by runbook index. Then we have relevant runbooks and AI guidance. Finally, human validation. Everything starts with an incident question. Production is slow, database latency is high, or payment failures are increasing. That's the real problem we are trying to solve today. Next, we organize knowledge. Our runbooks, our documentation, operational procedures are indexed and searchable. Then we try to retrieve most relevant runbooks according to the incident or problem which we are trying to search during an incident. This is important because AI should receive better context, not more context. Only now we are going to involve AI. AI reads the relevant runbooks and generate guidance for engineers. Then finally, we try to generate a final report which can be then validated by human. AI recommends, humans will decide. That's the exact pattern you are going to see in the whole series. Now let's jump back to our Visual Studio Code. Here, if you look at the runbooks, we have multiple different runbooks. For example, database latency, disk full, high CPU, Kubernetes, crash loop backoff. These are, let's say, some common real world operational situations in your company. These could be exported from Confluence or GitHub or any other location where you are storing these particular files, the format does not matter as much as the workflow. Let's try to open one of the sample incident. So this is the incident which we have. This is very simple. For example, checkout is slow and some users are seeing payment failures. Alerts: API latency is high, database connection pool exhausted, payment failure. Question: what should I check first? This is a simple incident. That's the kind of practical question this assistant should answer. Now, let's look at one of our runbooks. For example, database latency.md file. So, if you look at this particular MD file, it is a bit structured. I can see some symptoms here. API response time increases, checkout or login becomes slow, application logs show database timeout. It has first checks. For example, check database CPU and memory, check active database connections, check database connection pool setting, and some useful commands as well. kubectl logs deploy API service, kubectl top parts, kubectl get events, and some PostgreSQL examples as well. Finally, I can also see some common causes and also mitigation steps, escalation steps, and also final human validation. This is the kind of documents which we are going to see in our own projects. This is a bit structured, but in general, we will not have so structured or proper documentation. If our runbooks are, let's say, bad, AI output will also be messy. If we have better documentation, something like this, it might not be 100% correct, but 80 to 90%, this is okay. We will have better AI answer. That's the goal of this project that we are building today. Now let's start. So first I'm going to build the index. For that I'm going to say Python 3 followed by build index.py. Press enter. If you see index 6 runbooks, index written to index runbook index.json file. Now let's look at the build index.py script. Again, this is very simple script. It's not very complicated stuff. First, this particular script will read all the markdown files which we have in our runbooks folder. So here we have multiple different runbooks files. It is trying to read that. Followed by it try to tokenize the content. Then it try to store the title, file, content, tokens, token count in a JSON index. This is a simple local search index. This is a simple local search index. In a production system, you might use embeddings, you might also use a vector database, you might use so many different, services, for example, Elasticsearch, OpenSearch, Chroma. I mean, we do have a lot of stuff. I don't want to dig deeper into all of that stuff, but for this demo, we are keeping it simple and understandable. The point is not to hide everything behind a framework. The point is, let's say, here to understand the full workflow which we are doing. Now let's look at the JSON file. So I have runbook index.json file created. So if you see, this is a very huge file with a lot of stuff. So for example, I can see file, title, content, tokens. As we wrote in our script, we have the exact format output here. Now let's try to run this real quick. This is how our structure looks like in JSON file. We have a file, title, and content, and we have tokens as well. So this gives us a simple way to search for relevant documents. And again, this is not advanced RAG yet, but It shows you the core idea, converting documentation into searchable context and also retrieving the relevant pieces that are required during a production incident. Now let's search for relevant runbooks here. Our question mentions database latency is high and checkout is slow. What should I check first? In this case, the search system compares the question against the runbook index. Then we can see the output like this. Here, it scores document based on keyword matches and important incident keywords. This brought back our runbooks, database latency, and payment failure. This is important because we don't want to send every runbook to AI. If a company has, for example, 500 runbooks, AI should not read all 500 every time. We try to retrieve the most relevant according to our incident and according to the problem. Now, let's look at the retrieved reports. Retrieved runbooks.md. This particular report shows which runbooks were retrieved. It also includes the user question which we asked, and also we can see top matches. For example, we can see the match score of 63 and a portion of the runbook content. This is just, let's say, the evidence layer. Before AI gives us an answer, we know what documents it is using. That matters because if AI gives a bad answer, we can check whether the wrong runbook was retrieved. In real systems, retrieval quality is more important than model quality. We can use a very big model. With bad context, we are going to get bad answers. A smaller model which we are doing in this particular video, for example, Mistral, with good context can be very useful. Now let's try to open search underscore runbooks.py file and let's see what do we have in there. I am going to explain this on a very high level. Again, this is a very simple script. We are not doing complex stuff here. First, we are trying to load the runbook index. Then we are trying to tokenize the user question. Followed by, here we are loading the index. Then we are giving a score. Each runbook based on matching terms. That means it will try to boost database, for example, boost latency, payment, crash loop backoff. I mean, this is, let's say, very common if you work in real production environment. Definitely you are going to relate. And certificate issues are, let's say, very common. Crash loop is, let's say, another common word. So this is how we are going to boost some keywords. Then it sorts the runbooks by score and returns the top matches. This is not perfect, but it is transparent. In a real system, you could replace with this embeddings, but even then, the concept stays the same. Now, let's jump back to our local models. So, I'm going to check for Ollama. Here, I do have so many different models running locally on my computer. For this demo, I'm using Ollama with Mistral. You can replace with GPT, Claude, Gemini. It's up to you, or any other model. The model is not the product here. The workflow is the product. I am using a local model in this video because I don't want to send company's data to the outside world, even if the data is not customer data. Because runbooks can reveal lot of details about our infrastructure, our internal architecture, service names, I mean, so many different things. So local AI can be very, very useful for internal DevOps tooling. Now let's try to ask our AI Runbook Assistant. Database latency is high and checkout is slow. Payment failures are increasing. What should I check first? Press enter. But notice what exactly is happening here. We are first retrieving relevant runbooks. Then we give those runbooks to AI as context. Then we ask it to answer using only that particular context. The retrieval part finds relevant documents and the generation part creates a useful answer. Without retrieval documents, AI may hallucinate. Now let's understand what exactly we have in AI Runbook Assistant. So I'm going to open this file. First, it takes the user question. Then it tries to call the search function to find relevant runbooks. And it will try to build context from retrieved runbooks. Then it will try to build a prompt. You are a senior site reliability engineer helping during a production incident. This is very, very important here because we don't want the model inventing random commands. We want it to use only our internal operational knowledge. Then we add some rules. Do not invent systems, commands, or facts that are not present in the runbooks. If information is missing, clearly say what needs human validation. Separate immediate checks. Keep humans in control of production decision. Be precise and practical. And also return the answer in this exact structure. Most relevant runbooks, likely cost to investigate, suggested mitigation options, human validation checklist, confidence score. This particular structure is very, very important during incidents because nobody wants a long essay at midnight 1:30 a.m. Engineers need clear guidance for the next steps. For example, what should I check? What commands should I run? Whom should I escalate? That's what this particular script generates. Now let's look at the AI runbook answer.md file. I can see most relevant runbooks according to our question which we asked and according to the incident. I can see payment and database in this. Here I can see immediate checks. It is asking me to check. It also gave me the exact commands that I can use during an incident. Just checking the log files, for example, here, getting the events details. And also I can see likely cost to investigate, for example, payment gateway outage, API or secret rotation, network connectivity issue, slow query introduced by recent deployment. It gave me, likely causes to investigate and also suggested mitigation options. We are not blindly following this, we are going to validate it. Then I also can see escalation recommendation. This is the exact stuff which we asked the model to give as an output in our prompt. That's what we can see in the output. And also I can see commands to run here, PostgreSQL examples here. Also we have human validation checklist. Payment alerts are high priority because they may be directly affecting revenue. Do not assume database is the root cause only because latency is high. Validate with metrics, logs, recent deployment, history, and query analysis. What not to do? Avoid making changes without first validating the issue and its cause. Do not ignore payment alerts. And I can see some confidence score as well. Now let's try to generate the final report. For that, I'm going to say Python 3 final report.py. Press enter. So I can see final incident guidance.md file got generated. So what do we have exactly in this final underscore report.py? This particular final report combines AI answer with the retrieved runbook evidence. It also adds a human approval section. If you can see, we are trying to verify and also take some inputs from human. Is this incident still active? Is customer impact confirmed? Do logs support this suspected issue? These are, let's say, some of the actions we are trying to ask from human. This is the difference between a chatbot answer and an operational workflow. Now, let's look at our final incident guidance.md file. This final report is something you could imagine using during a real incident. You could paste it into Slack, attach it to the Jira ticket, attach it to the postmortem, send it to the incident commander, or use it as a starting point for troubleshooting. In a real company, you could extend this by reading GitHub runbooks, indexing service readmes, pulling service ownership. I mean, you can do a lot. Now, this becomes a real internal DevOps AI assistant. Let's try to do another test now. I am saying pod is in crash loop back off after deployment. What should I check? Press enter. We got the response here once again. Kubernetes crash loop back off runbook, and I can see the commands that I can run and also likely causes to investigate. For example, wrong Docker image, missing environment variable, config map missing. So whatever we have in our runbook, we are getting the same exact answer. Now let's look for disk usage is about 90% on production node. What should I do? We got an answer saying AI Runbook Assistant response. This full runbook, immediate checks. df-h, du, varlog, docker system df, kubectl describe node, likely cause to investigate. Log files growing rapidly. This is, let's say, one of the major concern that we see in real production environments. Old artifacts not removed is also another problem. Backup files stored locally. We can clearly see suggested mitigation options, escalation recommendations as well. So let's try to search for the last question. In this case, I will try to ask. Now let's try to ask another interesting question. In this case, I am going to ask coffee machine is broken, what to do? Press enter. No relevant operational runbook was found for this particular question. This assistant is designed only for DevOps, SRE, platform engineering, and production incident runbooks. All right. All right. We tested different incidents, different questions. Now let's go back to our blackboard and summarize what we have did today. The four important lessons we learned today in this project is documentation is useless if nobody can find it. Retrieval quality matters more than model hype. AI should answer from runbooks, not imagination. Humans approve production actions. These are, let's say, the four important lessons that we learned from this project. Now, let's try to summarize what we built. We started with a common production problem. An engineer needs help during an incident. The documentation already exists. The challenge is finding the right information quickly. So, first, we try to organize the knowledge into structured runbooks. Then we built a retrieval layer to find the most relevant runbooks. Only after that, we involved AI. The AI doesn't answer from imagination, it answers from our runbooks, which we retrieved. Then it generated the guidance, and finally, a human validated everything before taking any action. That's the type of workflow we have to use because Production systems are too important to blindly trust with AI. If you want this project, comment Runbook below. If enough people are interested, I'll definitely release the full source code. In this series, the next episode is about AI Terraform Reviewer. Thank you for watching, and I'll see you in the next video.